So in this video, we're going to be looking at how to graph parabolas using the transformations that we learned about yesterday. So before we start, I just want to recap from Unit 3 what the parent step pattern is. So for your base parabola, what is the step pattern? And that was 1, 3, 5, 7, 9, and it continues with all those odd numbers. Now before we get to graphing, we're going to recap what those transformations are for the parabola y equals negative 2, x minus 3 squared plus 4. So our a value is negative 2. Now the negative 2 has two meanings. The negative means we have a reflection over the x-axis. And the 2 means we have a vertical stretch by a factor of 2. And that's because the absolute value of a, the 2, is greater than 1. If it were between 0 and 1, then it would be a compression, so we're squishing down our parabola. Our h value is the value inside of our bracket, okay, which in this case is 3. Now the bracket says x minus 3, which means we're actually going to be moving to the right, shift right 3 units. And our k value is the one at the very end, which is 4. It's outside the bracket. And that's going to be shift up 4 units. Now these two shifts affect our vertex, and that's going to be our starting point for graphing. Okay, so if we look at our equation here, just like from Unit 3, we know that our vertex should be at 3, 4. Okay, it's from the h and the k value, and with the h value we're taking the opposite sign. Now it makes sense why, because of our shifts. If I'm shifting to the right 3 units and then up 4, that's going to move the tip of the parabola, that original vertex that was at 0, 0, 3 to the right, up 4, giving me 3, 4 as my vertex. So the first thing I'm going to do is determine that vertex, and then I'm going to plot it on my graph. So 3, 4 is right over there, and there's my vertex. Now I'm going to use my a value, and we know from the previous units that the a value tells us the direction of opening, and it tells us the new step pattern. So if my a value is negative 2, that means we're going to multiply that original step pattern of 1, 3, 5, 7, 9 by negative 2. So my new step pattern is going to be negative 2, negative 6, negative 10, negative 14, negative 18. Okay, and we did this in Unit 3, so this is nothing new so far. Now, from this vertex, I'm going to apply that step pattern. So from the vertex, I'm going to move to the right 1, and then I'm going to go down 2, and I'm going to plot that point. Then I'm going to move to the right 1 again. Remember, always 1 to the right. And then down 6. And now I plot this new point. And then I'd go to the right 1 and go down 10, but that doesn't fit on my graph. And now I do the exact same thing to the left. Or you can just use symmetry. Okay, if I go to the left 1 and down 2, I'm going to be opposite my other point. To the left 1, down 6, again, opposite the other point. And now I'm just going to connect my dots to get my nice parabola. And that's it. Now we can make some observations, which either from the graph or the equation, it doesn't really matter. So my axis of symmetry, remember it's an equation. It's a vertical line, so it starts with x equals, and it's going to be x equals 3 because the x-coordinate of my vertex is 3. But I'm going to draw that in case we forgot what the axis of symmetry was. Okay, notice it's passing through that x equals 3 mark. The direction of opening, it opens down, which we could have predicted because the a value is negative. And here's a little new part. What values can x take? What values can y take? Now, this you're going to get into more in grade 11, and we call it the domain and range. But we're just going to take a little sneak peek. So what values can x be? My parabola can extend forever. Okay, I can extend it down forever in both directions, which means if it goes down to infinity, these x values at one point they're going to extend really high. I can have an x value of 100, of 1,000,000, of whatever I want. Okay, so for any parabola, x can be any value. And the way we write that is by opening up kind of a squiggly bracket, writing x, and then we write this e symbol, which means element of, and then this fancy r, and then close the squiggly bracket. And this just means x is an element of real numbers. And there's no restriction. Okay, and by real numbers, that means it can be a whole number, it can be a decimal that terminates or that runs on forever, it can be a fraction, it can be positive, it can be negative, it can be 0, it can be anything. Okay, there's no restrictions for the x values. But if we look at the y values, we know our vertex is a maximum in this case. That means the maximum value of our y is 4. Everything else is less than 4. So the way we're going to write our range, so the values that y can be, we open up that squiggly bracket again. Now we're writing y is an element of real numbers, but there's a restriction. So we put the straight line and we say y has to be less than or equal to 4, and then close our squiggly bracket. So usually for these domain and range questions, you start with xer, yer, and if there's a restriction, then you put that bar and you write out the restriction. But like I said, for the domain, so with the values of x, for a parabola, they're always going to be anything. X is an element of all real numbers. X can take on any value. But the y is going to depend on that optimal value, the maximum or minimum of our parabola. All right, let's do a little bit more practice. So I'm going to walk through this next one once more with you. So our a value is 3, the h is -1, opposite sign, and the k is -2. So that a value of 3, because it's greater than 1, means we have a vertical stretch by a factor of 3. So we're going to expand our parabola. The -1 means we're shifting left 1 unit, and the -2 means we're shifting down 2 units. So what's our vertex going to be? Well, we just take the h from the k value. -1, -2. There's our point. Now we also have to figure out that step pattern. So I'm going to do it on the side. Okay, we're going to multiply the original step pattern of 1, 3, 5 by 3, and that gives us 3, 9, 15. And if we need more, we can go on, but it's really not going to fit on our graph. So I'm going to move to the right one, and now I'm going to go up 3. So here's my new point at 0, 1. I move to the right one, and now I'm going to move up 9, which just fits on our graph right over here. Okay, and then I'm going to do the same thing to the left, but I'm just going to use symmetry. So there's a point right here and a point right here. And now we can connect our dots, putting arrows at the end of our parabola for proper communication. The axis of symmetry is going to be x equals the x-coordinate of the vertex, so -1. Our parabola is opening up, and like I said before, domain, x can be anything. So x is an element of real numbers. The range now, let's look at our vertex. Our vertex is right here. It has a y value of -2, and everything occurs above the -2 mark. So your range, we start with our y is an element of real numbers, but now there's a restriction, and that restriction is that y has to be greater than or equal to the -2 that is the vertex. Okay, so that's it for this one. I want you to try the next one on your own. So pause the video, fill in A, H, and K, plot that vertex, figure out the step pattern, and then restart the video and check your work. Okay, so your A value is -1, which means you have a reflection over the x-axis because it's negative. But there is no other stretch or compression because the absolute A value is not greater or less than 1. H was -3, which means you're moving to the left 3. And then K was 1, which means you're going up 1. So what I did, I plotted my vertex, which was that -3, 1, right over there. And my step pattern, I multiplied it by -1 to give me -1, -3, -5, -7, etc. So here's my step. There's a step of 1. There's a step of -3. There's a step of -5. And then I ran out of space. My axis of symmetry, just like in Unit 3, is the x-coordinate of the vertex, so x equals -3. Parabola is open and down. Domain, just like before, x is an element of real numbers. But now our range, the maximum was at +1, so y had to be less than or equal to that +1. Let's go to the next one. So now we actually have a compression going on, so you might have to estimate that step pattern a little bit. Remember, in this case, we do have a missing k value. If you want to, you can put +0 there if it helps you with your vertex. But looking at this, my vertex is going to be 4, +4, comma 0. So I'm just going to plot that before I even do my transformations. Okay. And now the A value was 1/2. The H value is +4. And there is a K value of 0, which means we don't have any transformations. Okay. So go ahead and fill in the rest, and then we'll take it up. Okay, so that 1/2 meant you had a vertical compression by a factor of 1/2. You had a shift of 4 units to the right. So from the vertex, I found my step pattern by multiplying by 1/2 to get 0.5, 1.5, 2.5, 3.5, all going in the upwards direction. And then I just estimated that to get my points. The axis of symmetry was x equals 4, opens up, domain, no surprise, x is an element of real numbers. But the range had the restriction of y is greater than or equal to 0 because everything took place above the vertex, which had a y value of 0. Okay, last one is y equals -2x squared plus 9. Remember, if you do not like this format because you can't see that h value, we can rewrite it as x plus 0 squared plus 9. And that just means you don't have a right or left movement. Okay, so there it is, but there's nothing going on. The a value is -2. The k value is 9. If you guess that the vertex is at 0, 9, wonderful, which I'm going to plot. And then again, please state your transformations, find your step pattern, and then graph the parabola. Okay, so we had a reflection over the x-axis, a vertical stretch by a factor of 2, and a shift up 9 units. I didn't plot the rest of my points because I wanted to go through the step pattern one last time. So after I multiplied 135 by -2, I got -2, -6, and -10. So from that vertex, I moved to the right 1, down 2 to get this point. To the right 1, down 6 to get this point. To the right 1, down 10, which put me at -9. Now I use symmetry. Directly across from the point at 7, there should be another one. Directly across from the one at 1, another one, and directly across from the -9, the last one. Now, I just want to connect my dots to get that parabola, and again, I'm putting my arrows for proper communication. Last features, the axis of symmetry is at x equals 0. Again, the x-coordinate of the vertex. It's opening down because a was negative. The domain was x is an element of real numbers, because x can be anything for any parabola, and the range depends on the vertex, which has a y-coordinate of 9. So y has to be less than or equal to 9 because our parabola is opening downwards, and that vertex is a maximum. And that's it for graphing. Identify the vertex, identify the new step pattern, plot the vertex, and apply the step pattern. Put your arrows, connect the dots, and everything should be perfect.